And now we come to the last lesson in this unit. We're going to consider some applications of trigonometry in physics. You see, we don't always use trigonometry just to solve triangles. There are other very important applications. First, we need to learn a new word. The word vector in physics means that we're talking about a physical quantity that has magnitude and direction. For example, temperature has only magnitude, and it's meaningless to say that your body temperature is 37 degrees due north. So it's not a vector. The same applies to mass. 5 kilograms doesn't need direction to define it. Those are scalars. Scalar is the term we use for a physical quantity that only requires magnitude to define it. Examples of vectors are displacements, for example, where displacement is distance in a given direction. So when I say 3 meters due east, I am talking about a magnitude, which is 3 meters, and a direction, which is east. Therefore, it's a vector. And this is not distance, it's called displacement, because we're talking about a magnitude and a direction. A distance with its own direction. However, if I talk about 3 meters and I don't specify the direction, then I'm talking about a distance, and that is simply a scalar. Another example is force. And when you talk about a force, then you're talking about a magnitude, but also a certain direction in which the force acts. So force is a vector. So when we say 5 newtons to the right, that is a vector. We're talking about force. But if I say 3 newtons only, 3 newtons refers only to the magnitude of the force. And therefore it is not what we would call a vector. We represent vectors using arrows, such that the length of the arrow represents the magnitude of the vector, and the direction of the arrow represents the direction of the vector. So, in this case, I have represented 3 vectors. Consider the first one. Let's consider the blue one. I have 1, 2, 3, 4, 5, 6, 7 units, and you probably cannot see the arrow very well, but I have 7 units to the right. Now I can use this to represent a force. For example, 7 newtons to the right. Or I can consider it to be a displacement, 7 meters due east. It doesn't matter, as long as I identify the scale by the length of the arrow and the direction. So this is a vector. Another vector is the red one, and it could be 3 meters due north. In this case, the brown case is a slightly different one. We have a vector at 65 degrees south of east. And if you measure the length, you will find that it is 6 units long. So this is the way we represent vectors, irrespective of their nature. Now let's see the application. For example, I can deal with this problem of displacement. I traveled 5 kilometers due east and then changed course to travel a further 3 kilometers due north. Find my displacement. So let's draw this journey. I can represent this to be my starting point O, and then my 5 kilometers due east can be represented by this vector. And as you can see, 5 kilometers have been represented by 5 squares, and the direction, which is east, is done this way. Then I change course to travel 3 kilometers due north. So 1, 2, and 3, and this is my destination. Let's call this A. My displacement can be represented by this vector OA. It is the vector that takes me from the starting point to the finishing point. How can I describe this vector? If this is 5 units and this is 3 units, then my displacement D has a magnitude of, by Pythagoras, 3 squared plus 5 squared under the root. And I can justify using Pythagoras by the fact that I have a right angle here between the east and the north. This is 25 plus 9, so this is root 34. And this is your answer. This is exact, but if you want to calculate it in numbers that we can understand, then this is 34 under the root is 5.83 kilometers. To 3 significant figures. Now this gives me the distance that I traveled through. What about the direction? I can describe the direction by stating this angle, which is an angle north of east. How can I find this angle? 3 is the opposite, 5 is the adjacent, so tan theta equals 3 over 5, and therefore theta is tan inverse of 3 over 5, and this is let's make this a little bigger. Shift tan of 0.6, which is 3 over 5, and that gives us, say, 31 degrees to the nearest degree. That means that my displacement is 5.83 kilometers at 31 degrees north of east. A similar situation can be represented with forces. Let's say we have a body and a force of 6 Newton is acting on it due south. So 1, 2, 3, 4, 5, and 6. This is the first force. And the other force acting on the body is 4 Newtons due east. Now obviously, when you have a body under the influence of 2 forces in this direction, then it will move somewhere in between. And it's easy to imagine that we have equivalent forces to this, and you close the triangle. So this will be the net force. Let's color it in red. Now, Let's call this F. This will obviously be 4 newtons as well. So F by Pythagoras is equal to the square root of 6 squared plus 4 squared, and this equals the square root of 36 plus 16, which is 7.21 newtons. But what is the direction in which this force acts? We can work out this angle, theta, and we can see that tan theta is equal to 4 over 6, which gives us that theta is approximately equal to shift tan of 4 over 6, and that equals, let's say 34 for simplicity's sake, 34 degrees. So theta equals 34 degrees. So our net force is 7.21 newtons acting at 34 degrees east of south. Someone else might say, hang on a minute, I can work out this angle, and this would be 90 minus 34, which is 56 degrees, because we know that 34 is theta. So in this case, you can also describe the force as your net force as 7.21 newtons at 56 degrees south of east. Sometimes we need to divide the vector into two parts, into two components. So in this case, I have the resultant, the sum of the vector, and I want to divide it into two parts. So let's understand this question. I travel at 25 degrees north of west. So this is west and this is north. 25 degrees north of west is something like so, where this is 25 degrees. A friend needs to follow, and he wants to get to this point A, where this distance is 10 kilometers. How can he follow me? Let's say his problem is that he can only travel in north or west. So he can travel this path, along this path, until he is directly south of me, and then travel north. So what is this distance that he has to travel west? Looking at this triangle, x divided by 10 equals cosine 25. So x equals 10 cosine 25, and this equals 9.06 kilometers. So 3 significant figures. How about calculating y, which is the distance he has to travel? It's possible to use the sine ratio or to use Pythagoras. Now that we know that this is 9.06, let's use the sign. Y divided by 10 equals sine 25. That means that y equals 10 sine 25, and this equals 4.23 kilometers. Three significant figures. So my friend can follow me either by taking this route westwards and then this route northwards, or he can take an alternative route, which is 4.23 kilometers due north and then 9.06 due west. And finally, we have a force of 12.5 newtons at an angle of 30 degrees north of east. So if this is east and this is north, the force is at an angle of 30 degrees north of east. And it's acting on a body. Let's say the body is here. And I want to resolve this component, the force, into two components, one acting east and one acting north. So it's as if I'm saying I want this part here and this part here. Now, since this force is 12.5, then let's call this part x and let's call this y. Then my two components are obtained by the following: x divided by 12.5 is equal to cosine 30, and you can solve that. Y divided by 12.5 is equal to sine 30. Do the calculation, find x and y, and you can tell what the components of this force